So welcome to GLC webinar. So today we'll be talking about the SSL Certificate Mikrotik. My name is Achmad Mardiansyah and I'm from GLC Networks. The agenda today we'll be talking about introduction, the SSL Certificate, Mikrotik SSL Certificate, and some demo. Okay, some screenshot for showing you the generating certificates applied on Mikrotik service. About the GLC itself, we are Indonesian company. GLC stands for Garda Lintas Cakrawala. We're based in Bandung. Our area are IT consulting and then training. We are Mikrotik certified training partner, as well as Ubiquiti and then Red Hat. Okay, next about the webinar itself. So we start the webinar since 2010, so it's a new year. Yes, correct. At the time, yeah, thank you. At the time, we talk about the Solaris operating system. So as you know, webinar is a sharing event with various topics, including Linux, networking, wireless, database, whatever. Our regular schedule is every 2 weeks. Irregular schedule is as needed. You can check our schedules on our websites, glcnetworks.com/main/schedule. If you want to be a presenter, feel free to do so. You don't need to be an expert. This is just a forum for sharing knowledge, experiences, information. Right, so my name is Ahmad. So about myself, I'm based in Bandung. I'm Linux user since 1999, Mikrotik user since 2007, using Ubiquiti since 2011, certified trainer for Mikrotik, Ubiquiti and Red Hat, certified consultant, previously working as a telco sysadmin programmer. Personal website is here, amazjournal.com. For more information, you can go to my LinkedIn page. Okay, so about yourself, I think we have enough. We can just keep carrying on. Right, so SSL certificate, yeah. Yeah, certificate on Mikrotik. Oh, sorry. Oh, I don't think this is a correct slide, so there must be a mistake here. Sorry about that. Okay, let's continue. So next slide is about SSL certificate. Yeah. So before we go into the certificate itself, we need to talk about the security itself. So we can group the security into two groups: end-to-end security and intermediary security. It means end-to-end means, as the name suggests, it's from the end device to the another end device. Okay, so from example is the principal aspect of the end-to-end security are non-repudiation. It means you can deny what you have done. Data confidentiality, data integrity, privacy. Okay, while intermediary security, that could be communication security, availability, access control, authentication. Yeah, so that was the difference between intermediary devices, intermediary security, and then end-to-end security. So one aspect of end-to-end security is confidentiality. Okay, confidentiality means it's end-to-end security. Okay, so it's to ensure that the authenticated party can only authenticated party can read the data. Okay, others cannot. So the technique we can do for that is encryptions, and in these encryptions we have symmetric encryption and then asymmetric encryption. So on the picture here, so for example on the left I'm sending to the right here. So left and right can be from laptop to PC, server, or server to laptop. Okay, you can change it to any, yeah, so it's just like a symbol from A to B, yeah, from left to right. So from left I encrypt the plain text here, hello, and then it's encrypted. Okay, at the end when the message is arrived, and then it's decrypted, and then I can get the original message. So as simple as that. Okay, that's the confidentiality. So that is the symmetric the concept of encryption. So the encryption itself divided into two, okay, as discussed in the previous slide here. We have symmetric and asymmetric encryption. So if we have symmetric encryption, it means that they are using same cryptographic key for both encryption and decryption. Yeah, so the key that is used here is same. Okay, same algorithm, same key. You can think key like it's like password, yeah, so same password for encrypt and decrypt. Okay, so password is 123, to decrypt password is 123, and then you can see. Okay, so similar like you put password on PDF, you put password on zip files, yeah, symmetric encryptions. So sometimes requires secret string on both party. Yeah, so both party, in order to increase the security, they are sharing a secret. Yeah, so both party must understand the same string. Yeah, secret string. Okay, so only party that has secret key can understand the message. Otherwise, you just see the ciphertext. Example: symmetric algorithms are two-fish, blowfish, RC4, triple dash. Yeah, so those are example of symmetric encryption. Okay, what about asymmetric encryption? So we use pair of keys. Yeah, so first is public keys, which may be widely spreaded through the world. Yeah, so you give public key to everybody. Yeah, and then private key. So as the name suggests, it's a private key, so it means it's only for you. Yeah, only the owner has the key. So if you want to send to somebody using asymmetric encryption, so you must get their public key first before sending the data. Yeah. Okay. So if you want to send me, you have to please give me your public key. Okay. So if you want to send me using asymmetric encryption, so please give me your public key. So where's your public key? Here's this is my public key, and then you use it, and then you can use the public key for encrypting the message. So sometimes in order to increase the security, you exchange your public key when you have physical meeting. Yeah, so when I'm in Red Hat, between trainers we are exchanging key, or in other company, yeah, so we are exchanging key, public key, when we are meet each other. Okay, so this is you, I see you, and then so I know you, this is your sometimes they require me to check the password. Yeah, so do you have any ID, like yeah, you know, national ID, passport, or driving license, any ID, the ID that's showing you that okay, you are the right person. Yeah, so you give public key to the person. Okay, and the person will save your public key. So when they want to send a message to you, they will use your public key. Example algorithm are RSA. Yeah, it is very famous. RSA stands for Rivers, Shamir, and Edelman. Another example is Diffie-Hellman. So here, encryptions, we use public key, and then when it arrives to you, okay, you can decrypt it with the private key. Okay, so this is public key on the left, and then private key on the right. Okay, So how does the key looks like? Okay, yeah, so it looks like this. Yeah, it's not so good. Yeah, so on the left this is the private key, on the right this is the public key. Okay, that's how the key looks like. Now it's about HTTPS. Yeah, so HTTPS is a technique to secure HTTP communications using port TCP port 443. Okay, and HTTPS is using asymmetric encryption. So here's the steps. So on the left we have client, on the right we have server. So number one, step one is you are sending a request, yeah, HTTPS blah 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 blah, and then the server respond with public key. All right, public key. See, so whenever you want to send something, you have to download their public key first. Yeah, see on the step number 2 here. So you download the public key, and then step 3, you check whether this public key is certified by an authority or not. For example, yeah, it's like an organization that that certifies. Oh, okay, your certificate is good. Okay, some examples are Google. Yeah, Google is one of the certificate authority. So the one that is certifies that your public key is correct. Yeah, certified, that guarantee. Yeah, like Komodo SSL, like Let's Encrypt. Yeah, many certificate authority. Yeah, you can just Google it. Okay, after it defines, okay, the public key that I got from the server is correct or legitimate, and then continue to step number 4. You use that public key here and send the request. Okay, so encrypted URL data will be sent using the public key. So so the data here is already encrypted. Number 5 is verify certificate. If clients also required to provide certificate, yeah, so checking to the certificate authority, it's not for server side but also client side, so both party must be signed by the same authority. Yeah, so both party, client and server, are legitimate. But step number 5 here often is ignored. Yeah, especially for public server. For private server, private server for military or for internal highly secure organizations, usually they require clients to have a certificate as well. Okay, once the clients send certificate, after we verify client certificate from the clients, and then we reply with the requested resources, requested documents, and then still it's encrypted. Okay, and then 7 and 8 here, so we decrypt and then encrypt, and then until the communication done. Oh, simple as that. Yeah, so that's HTTPS. Okay, what about CA? Yeah, so CA, certificate of authority. It's like yeah, you know, it's like a certificate of when you have a certificate like vocational certificates like MTCNA. Yeah, so Mikrotik become the certificate authority. So it's an organization that you can verify your certificate. So if somebody claims that, okay, I have done MTCNA and then this is my MTCNA number, and then you can verify that MTCNA number on CA's website. Understand? Yeah. So you just go to Mikrotik website and then type the certificate number, and then the information will be appear to you. Okay, showing that, okay, this certificate number is valid is owned by this person. He was taken an examination on this date. Yeah, so certificate authority, it means that the organization that guarantees your certificate, okay, that has information for your certificate. So you can ask them, you can ask certificate whether a certificate is legitimate or not. Okay, so what happens when a web server has when a web server has a HTTPS, but it's not registered to certificate authority. Yes, we can do encryption. Yeah, same grade as other encryption, but it's not legitimate. So that's why on browser you will get a warning here, like on the picture on the left. Okay. So what happened when you register certificate to CA, certificate authority? So it means that your public key, yeah, will be added, is combined with the certificate of CA, and then you will add more information. So not only the public key, so the CA will add some information on your public key. Understand? Yeah. Okay. Yeah. So again, if you have two choices. So if you run a web server and then that web server run HTTPS, you have two options. So first option, you can create your own certificate. So I sign my own certificate. Okay, I guarantee my own certificate. So that's why your browser doesn't recognize it. Yeah. So every browser, if you want to know here, if you want to see on their list, every browser has CA's public certificate. So, but the problem is, how does browser knows about the certificate? Yeah. So because every browser has CA's certificate installed. Yeah. So we don't have to ask, we don't have to query the CA's website to check whether the public key here, public certificate, is legitimate or not. Okay, because we already have CA certificate. Yeah, so on Chrome, Chrome browser, Firefox, Opera, whatever. Yeah, so they have a CA's public certificate. Okay, so that's why they don't have to go to, they have to contact Google, they don't have to contact other CA certificate website to check whether the public key is legitimate or not. So the way they do, so once again, so I'm just repeating what I'm saying. So if you decide, so first option is self-sign, second option is you ask CA, certificate authority, to sign your public key. Yeah. So if you choose the second option here, your public key will be added information from the CA. Okay. So what about on Mikrotik? So certificate usage on Mikrotik can be used on many services. Yeah. So first, HTTPS. Yeah, that's obvious. I think that's the most common. Yeah. Second is PPP. Yeah. For example, for SSTP. Yeah. So that one you can use certificate as well. OpenVPN. Okay. IPsec wireless authentication. Yes, we can do it with the certificate. Okay. And then etc. etc. If I forgot other application that requires certificate usage. Mikrotik itself has certificate too built into the RouterOS, but the key is only known by Mikrotik. Yeah. Okay. So I have one question here from Shamil Kedua. When I open a browser, but the date of the computer is not is not matched with the certificate, yes, and then browser requests the certificate, yes, that's correct. So again, certificate is really sensitive with the time. We will check it out, yeah, we will check. So certificate is not forever, so we have start date and end date of certificate. So if the computer time is not on that range, and then there will be a warning. So this is one example of creating self-signed certificate on Mikrotik. So you just put the name here, country. Oh, sorry, you have to put country with 2 digits, ID, so this one is wrong. State, local, organization, unit, common name, yeah, and then we use DNS. How many days valid, yeah, so how long is the certificate valid, key size, yeah, how many bits, and then after that you click OK and then check the status. So at the moment the status is 0. Okay, so not invalid before is empty, invalid after is empty. Okay, start and end, yeah, begin and finish, yeah, date where the certificate is valid. Okay, so you have done, but status is not active. So how do you do that? You sign the certificate using the same certificate that you have created before. You click here sign, yeah, on the bottom on the right, click sign and then pick certificate that is used for signing process. So in this case we use the same certificate, yeah, cert minus hotspot 1. You click sign, it takes a while, maybe several seconds or several minutes. Because why it takes so long? Because generating a key, yeah, for example for longer key, in this case I use 2048 bits. So if you generate longer key and larger key, for example for 4096 bit, it takes longer, yeah, maybe it takes several minutes on low end Mikrotik device. In this case I just use 2048, so that won't take long, only several seconds. Because generating a key requires CPU calculations, yeah, so that's why when you're generating a key your CPU is going to be high, CPU usage. So after you sign, and you can see here the status is already active, yeah, so you can see the fingerprint, and then here's the important thing is the valid date, yeah, start from here up to here, so between them is valid. Okay, so start from August 31st and 2017 up to August 31st 2018. So before this is invalid, after this is invalid. Okay, so it has to be between the date. Okay, so again, certificate is really time sensitive. Okay, next is apply certificate on HTTPS service. Yeah, so you just go to IP service and then go to SSL and then pick the certificate that you just created. You click enable and then done. You can access it from your browser. But because you sign the certificate by yourself, yeah, self-signed certificate, the browser will give you a warning. As you can see here, hotspot.glcnetworks.com, yeah, that's the IP address of the routers. I've set it up on my DNS server. It will give you a warning. Why? Because the certificate that I created here is not signed by a legitimate organization. Okay, so as you can see here, issue common name here, issued by myself, as you can see, yeah, issued to and issued by, yeah, same person, yeah. So it's like, okay, I'm past the MTCNA by myself. Okay, so I'm the one who is guarantee myself that I have passed MTCNA. Okay, so next is importing legitimate certificate. Yeah, so that's what you can do to create a self-signed certificate. Yeah, you create a certificate, sign, and then apply it on your service. Okay, when you access it with your browser, there will be a warning. Okay, why? Because our public certificate is not guaranteed by a CA. So what should we do? Yeah, in order to avoid warnings on browser, so we can import legitimate certificate. For example, this one. Yeah, we can import. So we generate certificates. So for example, we get it from Google, get it from GoDaddy, get it from Komodo SSL, GeoTrust, Star SSL, or Let's Encrypt. Yeah. So here I get certificate from Let's Encrypt. Yeah, for hotspot.glcnetworks.com. And Let's Encrypt is one of the CA, so I got it from them, and then I apply it on my Mikrotik. Yeah, so I import it. Yeah, and then status is trusted, and then the invalid before, invalid after. Okay, and then click here, and then apply it on your browser. Done. After that, your browser will not give you a warning. Okay, so that's all for today. Yeah, for today's webinar. So hopefully you can learn it. Yeah, if you have any difficulties, you can ask the questions. If you are interested, you can join our training. Yeah, check on our schedule. And yeah, if you don't mind, you can submit your feedback here. Okay, I have one question from Shamil Kadua. Is certificate on Mikrotik is limiting time for using Mikrotik based on the begin and expire set that we already set? I don't understand. Look, as you can see here on the certificate, so the certificate, when you, for example, you have hotspot, and then you want the customer to log in through hotspot using HTTPS. Okay, why? Because you don't want their password or username to be sniffed by other people. Yeah, so that's why you want to have HTTPS for hotspot login. Yeah, so HTTPS certificate must have a validation date here, invalid before and invalid after. So which one is valid? The valid date is between them. Okay, so yeah, if your router's date is between this time, and then that should be no problem. Okay, but if certificate on Mikrotik is limiting the Mikrotik usage, no, it's not. It's different. Yeah, for limiting the time, you can use a radius. Yeah, for example, you can you are limiting usage of user to be 2 hours. So maximum of online access of your customer is maximum of 2 hours. So that kind of limitations or rules can be applied on radius. Okay, so hopefully that answers the questions. Any other questions? Do you understand what we are discussing here? Okay, any other questions? Okay, any other questions? No? Okay, if there is no questions, and then thank you for coming. Yeah, hopefully see you again on the next webinar. So next webinar, I think, so this webinar today is supposed to be done last week, okay, because last week we had a problem. Yeah, so the webinar is moved to this week. Next webinar is happening on next week. Yeah, and then there will be an adjustment on Friday. Yeah, so we'll be having a webinar on Friday next week. Okay, what else? Yeah, not on Saturday, so still next week, but on Friday. And then the topics for the next webinar is wireless essentials for with Mikrotik OS. Okay, thank you very much. Hopefully you enjoy this webinar. See you again in the next meeting. Bye.